Okay, the first part of your homework will be to read through this information and this information. When we talk about devices, there are two types, analog and digital. Analog devices have tick marks. Examples include meter sticks, the old-fashioned mass balances, where you place something on a balance and then you get the hanging weight and see how far you can slide the weight over. And another example is an analog clock, which has a minutes hand, an hour hand, and a seconds hand. All of these have tick marks. Digital devices, by contrast, just tell you the answer. They tell you the measurement. For example, if you have a digital thermometer, there's a screen and it just reads off the value. When you are working with analog, that's tick marks, there is some smallest increment on the device. Maybe it's 0.01 centimeters, or maybe it's 0.1 grams, or maybe it's 1 second. The interval, the smallest interval or increment on the device, you take it and you cut it in half to get the absolute uncertainty. For digital devices, you simply take 1 in the last measured place, or in other words, the smallest increment. That's the uncertainty, absolute uncertainty for a digital device. However, these are the minimum values. You are allowed to select uncertainties higher than these values, higher than the smallest increment, or higher than half the smallest increment. Sometimes we do estimate our uncertainties to be higher. Okay, we're going to skip this one, but there was a typo anyway. The idea here is that if they don't tell you what the uncertainty is, you just assume plus or minus 0.1. Why? Because it's a digital device. Okay, vectors and scalars. This is something we know well. Vectors have magnitude and direction, scalars just magnitude. That said, the magnitude, there are cases where there's negative magnitude, right? Celsius temperature. Simply because there's a negative doesn't mean it's a vector. Scalars can be negative too. We use arrows to represent vectors. Here's a list. This is a good list to memorize for the test. Energy, this could include kinetic, potential. Those are the two types generally. Potential, the two types that we deal with. Field strength, this could be gravitational field strength. How strong is gravity? It could be electrical field strength. And it could be magnetic field strength. Oops. This is a good list to memorize. Another one though, first. Another one we have to add for a scalar. Oops. Charge, electrical charge, and electrical current. Those are both scalars, believe it or not. So add those to the list. Okay. On to vector drawings, tip-to-tail drawings. If you're ever asked to add vectors graphically, graphically means using the tip-to-tail method. So for example, let's make A red and B will be purple. You take those vectors, connect A and B so that the tip of A, here's the tip of A, connects to the tail of B. That's tip to tail. The resultant, the sum of the two, is tail to tail and tip to tip. So you are going to practice 107 through 110, and now then you'll do the remaining practice. But first, let me explain subtraction. There are two ways to do vector subtraction. Let's say we have A minus B equals C. Here's vector A, here's vector B, and we're trying to find what C is. If you take this subtraction, you can rewrite it as an addition. So I'm going to bring b to the other side, and now I'll have a equals b plus c. So a is actually the resultant. B and C, those have to be added tip to tail, so that A is the resultant. Okay, how does this work? You connect the two tail to tail. Again, here's why. A is the resultant. So it has to be tail to tail with one of them. Might as well make it tail to tail with B. Second thing, now we draw C so that it's added tip to tail with B. How did I know to go across? Because I knew that I had to connect so that A, again, was the resultant. A has to be tip to tip and tail to tail. But C has to be added tip to tail with B. Let me show you now the other way to do this. You could say that C is A plus negative B. In this case, now we do have a proper addition. C is the sum of A plus negative B. We know what A looks like. We've already got it written. But what's negative B? You take the exact same vector and you put the arrow on the other side. So now you take your A vector, you take your negative B vector, you add them tip to tail, and the way I've written this, C is the resultant of these two. So I draw C tail to tail and tip to tip. And this gives the exact same answer as before.